Good morning, students. This is Math 2008. Today is June 13th. We are recording our lecture, and we're going to start a new chapter, Chapter 4, Section 1. And the homework assignments for the three sections that we will cover from Chapter 4 have been uploaded, but you won't be able to do all of them because we will do only one section today. Hopefully, by the end of today, you will be able to do problems from 4.1. Try them. Before I start 4.1, I have a student who wanted me to do a particular problem. I'm going to do that one first. It's a problem from section 1.2. So she wanted me to do, let me see if I can find it. She wanted me to do part D. Here's the problem. So I'm going to go over it. And again, I'm repeating myself. You can always ask me to do certain problems. Now, the student asked me to do part D. I'm going to do part D. Now, part D is a little tricky. Okay, let me see if I can make it a little bigger. It's basically, you can pretend this is the sequence they're talking about. I'm going to rewrite it here because there will be a little less distraction. Give me 1 second. Let me see. So the first one is 9. The next one is 9 to the power 4. 9 to the power 7. 9 to the power 10, comma, dot, dot, dot. Now you to find, they want you to find the 100th term and the nth term. Now I'm going to get rid of the question if you don't mind, okay? So I need the room on my screen. My laptop screen is not the largest, so I'm going to get rid of this. But you want to remember, they want you to find the 100th term and the nth term. Now, some people like to find the nth term first and replace n with 100. Sure, that'll work. I'm going to find the 100th term first. Let's get rid of this. Now, I'm going to do one more thing. I'm going to write this as n to the power 1. Now, look at the powers. 1, 4, 7, 10. To me, it looks like it's an arithmetic sequence. I'm going to write down just the powers. 1, 4, 7, 10. It's clearly an arithmetic sequence, right? It's going up by 3, and the common difference is D, which is 3. So let's forget about the main question for a second. So the first term is 1, the second term is 4, the third term is 7, the fourth term is 10, so on and so forth. Now I want to know the 100th term. Well, I can do that. I can say, well, the 100th term is a subscript 100. And remember that famous formula, a subscript 1 plus n times d minus 1, n minus 1 times d. So d is the common difference, a1 is the first term, and here it will be 100. But let's write it in terms of n first. It really doesn't matter. Now, I'm going to replace n with 100, and a1 with not 9 to the power 1, but with 1. I am talking about this sequence, okay? Don't forget it yet. And d is 3, and n is 100. 100 minus 1 is 99. And this is going to be 99 times 3 plus 1. Let me use my calculator. I know some of you can do it in your head, and good for you. 3 times 99 plus 1, 298. I think you can see what's going on here. Now, the 100th term is going to be, if you look at this sequence, the 100th term will be 298. So if you look at this sequence, I know it's not an arithmetic sequence, but the powers are. So you can write the 100th term, sorry, a subscript 100 is going to be 9 to the power 2, 9, 8. All right, so I got the 100th term. The nth term, I'm going to go here, take the same formula, and replace the first term with 1, right? Because I am talking about this sequence. All right, that's what I'm talking about. The first term is 1, d is 3. And then I can simplify it further as follows. I'll try not to make too many mistakes. 3n minus 2. All right, the nth power is going to be 3n minus 2. So what's a subscript 100 or a subscript n? That's going to be a subscript n is going to be a power of n raised to the power 3n minus 2. So those are my two answers. Okay, I'm going to put my final answer in a pink box or yeah, in one pink box. Now, these are your answers. Okay, the catch is you look at the powers, you focus on the powers, and they don't kind of expect you to. You look at the numbers, n to the 1, n to the 4, n to the power 7, n to the power 10. The powers are in arithmetic sequence. So I hope that helps. Um, the person who wanted me to do this, here it is. All right. So moving on, moving on. We are going to work on chapter 4, section 1. I have kind of my notes. I'll tell you what I mean. I pick the things, the topics that I want to go over from your book, and I simply talk about them, okay? And you want to read the chapter, okay? Um, it's an online asynchronous class, so you want to read the chapters or sections. All right, so we're going to divide. Okay, what are we going to do? Let me actually go over a couple of things first. First things first. All right. You want to know these terms, and most of you are familiar with them. What are integers? Okay, integers. Okay, it's a set of numbers, and these are the numbers. I'm going to put curly braces. Okay, this is the set of integers. All right, integers. This set is written like this. I don't have a good way of writing it. So this is a Z, and I don't know why they use Z, okay? But this is how it's written. I'm not going to worry about it. This is your set. What are these numbers? This is 0, plus minus 1, plus minus 2, plus minus 3, goes on and on in both directions, right? What are natural numbers? Let's write them down. Natural numbers are these. I'm going to put them in a set. 1, 1, 2, 3, 4, dot, dot, dot. So these are basically positive integers, right? Positive integers are natural numbers. What about whole numbers? Whole with a W. Whole numbers is this. These are the whole numbers. So now, how can you say it in simple words? First, if you understand integers, you can say natural numbers are positive integers and whole numbers are non-negative integers. When I say non-negative, I mean this. So again, you have to remember it, okay? I'm going to use these words a lot. Integers or set of integers is 0, 1, plus minus 1, plus minus 2, plus minus 3, plus minus 4, goes on and on. Natural numbers, 1, 2, 3, 4, goes on and on. Whole numbers, 0, 1, 2, 3, 4, goes on and on. Got it? We'll be talking about whole numbers. We're not going to be talking about fractions too much in this section, chapter 4. Okay, I'm going to save this here. I might come back to it, might have to, but really now we're going to start our main topic from 4.1. Okay, we're going to talk about what does it mean for a number to divide another number. And you guys know what it means really. For instance, we say that 12 is divisible by 3 because when I divide 12 by 3, I get a whole number. We'll be mostly talking about positive integers. Okay, occasionally we'll run into 0, which is whole number. Actually, I can also say we'll be talking mostly about whole numbers. So what does it mean? This little strip of text that you see on top is taken from your book, 4.1. It reads, for any whole numbers A and B, if B is not 0, B divides A if and only if there is a unique whole number Q such that A is BQ. So here is one example, and it's a fancy way of saying this, guys. 12 is equal to 3 times 4, okay? We say 3 divides 12 if you can find a whole number, which is 4 in this case, which is 4 in this case. It sounds a little convoluted. I do understand that, okay? So, but it actually makes sense. They're trying to be precise. So they're saying 3 divides 12. If you can find a whole number, 4, in this case it's 4, and if you can multiply 3 by 4 and get 12, then we are going to say 3 divides 12. So informally, a number divides another number if the answer is a whole number. Okay, and this is called the divisor, and this cannot be 0 because we don't know how to define division by 0. You never divide a number by 0. All right. So once again, let me give you one more example. Let me get rid of this. So what about this one? 50. 50, 10 divides 50. 10 divides 50, clearly because the answer is a whole number. You can also say, if you want to stick to this definition, you can also say, well, 10 divides 50 because 50 is equal to 10 times 5, and clearly 5 is a whole number. Okay, and clearly 10 is not 0. So again, it may seem a little technical to you guys, but it makes sense. That's how we define divides. All right. So 50 is divisible by 10, or we can say equivalently 10 divides 50. Okay, not the other way around. 50 doesn't divide 10. All right. 7 doesn't divide 50 because if you divide 50 by 7, you're going to get a fraction. You're not going to get a whole number. All right, guys. I hope that makes sense. Let's go to the next one. Okay. Now, this is not a difficult idea. It's, I'll tell you what will throw people off. For any whole number, A and B, A and D, if D divides it, by the way, when you write D, I'm going to write it here, and you want to be, when you say D, a vertical line, A, it's red. D divides A, not the other way around. And N is any whole number, then D is equal to NA. Actually, the two are very, very related, very much. So all we are saying is a number divides another number. For instance, I can say 7 divides, it's just a vertical line, okay? Divides 14. Why? And A and D are whole numbers. Excuse me. The smaller one divides the bigger one, and N is any whole number, then D divides N A. That makes sense, okay? I'll tell you why in a second. So it doesn't matter what N is. If you multiply 14 by N, N could be anything, let's say 50. It will still divide that number. So I'll show you like this. I'll show you like this. It'll hopefully make a little more sense. So take a number. Let's take our example, 14 divided by 7. Okay, we write 14 divided by 7 like this, but when we do it like this, it's 7, it's read 7 divides 14, or 14 is divisible by 7. Now, clearly the answer is 2, right? Now multiply 14 by anything, anything. Let's do it here. Multiply 14 by anything. Let's just take n and divide by 7. You'll still be able to divide n is a whole number. You'll still be able to divide 14 by 7 and get 2. The answer will still be a whole number. It's going to be 2n. That's kind of what they're trying to say. It's kind of intuitively makes sense. Um, and the way I explained it, hopefully it will make sense too. So if 7 divides a big number, if you multiply that bigger number by any whole number, 7 will divide that bigger whole number. So these two definitions are very much related. Hope that makes sense. A couple of other little things, then we'll dig into something a little deeper today. Let's see what else is coming up. All right, let's see. Go to a new slide. So your book explains these, and I will try to explain it informally myself in my own style. You can read the text in your book, and you can, of course, hopefully you'll watch my video as well. So no big deal. So what this is saying, guys, I'm more interested in the first three. Okay, don't worry about the last two. Intuitively, it should make sense, but I'm not going to worry about them. A and B are whole numbers, and D is also a whole number, and D is not zero. So you have D dividing A, D dividing B. If D divides a whole number A, all numbers we're talking about are whole numbers, and D has an added condition, D cannot be zero. So if D divides A, D divides B, then D must divide the sum of A plus B. It's fairly easy to see. Okay, so take a look at this. Okay, 5 divides 15, and 5 divides 25. Now add 15 to 25. 15 plus 25 is 40. 5 will divide 40. And that makes a lot of sense. 5 divides 40. Well, look, I'm going to show it to you this way. 40 is equal to 40 divided by 5. I better get a whole number, right? Clearly 5 is not 0. But instead of 40, I can write 25 plus 15. Of course I can, because 40 is 15 plus 25. I can write it. But 15, I can also separate it like so. And clearly, 15 is divisible by 5. 25 is divisible by 5. That means I'll get whole numbers as answers. right? And if you add two whole numbers, you're going to get another whole number. So clearly 40 divides 5. Using the same technique, you can say here, you can use the exact same technique to explain this one and this one. Very similar. And this is, I'll show you this one. Actually, let me show you this one, C. Okay. I'm going to use the same examples. Let me show you C. Let me work on C. So if a number divides A, which is 15 in my case, and B, which is 25, I'm going to claim, I'm going to claim 25 minus 15 is 25. What's going on here? But we'll figure it out. Okay, 5, 5. What's 25 minus 15? 10. All right, so we're working on C. In a very similar way, I'm questioning if 10 is divisible by 5. Instead of 10, I can write 25 minus 15. And 25 minus 15 is 10. But I'm going to write 25 over 5 and minus 15 over 5. Clearly, 25 is divisible by 5. I'll get a whole number, which is 5. And 15 is divisible by 5. I'm going to get a smaller whole number, which is 3. And 5 minus 3 is also a whole number. So really, what I'm trying to say, guys, I want you to kind of understand this. I don't think you'll use it too much. And they're saying, this one is saying, if it divides one, but not the other, then D will not divide the sum. This is same as C. If it divides one, not the other, then the difference is not going to be divisible by D. Here it's the same deal. Here it doesn't divide A, D doesn't divide A, but D divides B, so the difference will not be divisible. I'm more interested in A and C. So basically, in summary, they're saying if a number, whole number, that's not zero, divides a number A, and it also divides a number B, then it will divide the sum of those two numbers and the difference of the two numbers, positive difference where A is larger. And it's very intuitive. I have the explanations here. So that's that. Okay. The main uh, topic in this section is or are divisibility rules of different numbers. So some are very easy, two of them are difficult. I'll try to explain it and we'll see how things work. All right. So this is called the divisibility test. And I'm not going to explain it going on. I mean, I won't prove it, but I'll prove the hard ones. How's that? And this one you guys know. Okay. If a number is divisible by 2, if and only if its first digit, this digit, it's called units digit. So it's basically this. I can give you a large number. This number, okay? This number is divisible by 2 because its units digit 6 is divisible by 2. Basically, if a number is even, what are even numbers, guys? 2, 4, 6, 8, so on and so forth. If the first digit or the units, this is called the units digit. If this is divisible by 2 or if this is even, the number is divisible by 2. Well, that's something you guys probably intuitively knew. Divisibility rule for 5. Okay. If a number is divisible by 5, it's divisible by 5 if its units digits are 0 or 5. Okay? If the last digit is 0, the units digit is 0, the number is divisible by 5. For instance, 10, 20, 30, 40, 330, 340, all those things. 15, 25, the units digit is ending with 5, it's divisible by 5. All right. A whole number is divisible by 10 if and only if its units digit is divisible by 10. That is, if and only if the units digit is 0. If a number ends with 0, it's divisible by 10. Those three are easy, okay? Fairly easy. Most of you knew it intuitively. Now we're going to do some hard ones, and I'm going to give you a little more explanation why it is true. Okay, if you read your book, you're going to see they explain it using ABC, and I'm going to avoid that because it's a little hard for our students to follow. Let's try the divisibility test for 4. What are they saying? A whole number is divisible by 4 if and only if the last two digits of the number represent a number divisible by 4. Well, what's that supposed to mean? Well, this is what they mean, guys. This is what they mean. All right, so let's take a number, 16. Now, I'm only concerned about the last two digits, okay? Now, it's a large number, right? I am only concerned about the last two digits, which is if you separate the last two digits, what number do you get? Well, you probably get 24, isn't it, guys? Is 24 divisible by 4? The answer is yes. 24 divided by 4 is 6. 6 is a whole number. Yes, it's divisible by 4. So is the whole number. It's 166,724. What about this number? Let's just change the last digit to 25. Well, 25 is not divisible by 4. 25 is not divisible by 4. So this large number, 166,725, is not divisible by 4. So let me test it. Does that make any sense? So I'm going to show you the first one is divisible by 4 as follows. 166. Okay, that's a whole number, 41,681. All right, what about this? That's not a whole number, 41,681.25. So the test seems to work, right? Now, why is it true? I'm going to give you an example, okay? I'm going to give you an example. Take any number that has more than two digits. I'm going to take a simple case, okay? Fairly simple case. Your book does it with ABC. I'm going to take 324. I can always write 324 as 3 times 100 plus 24. Now, I want to divide both sides by 4 because I'm doing that divisibility test, the divisibility test for 4. Okay, so I'm going to divide this left-hand side by 4 and the right-hand side by 4. Yeah, that's how you do it, right? That's how you would divide. Now, I really don't have to worry about this part. This will always be divisible by 4 because this number has 100. 4 will go into 100 and you will get 25. So you'll get a whole number there. If you get a whole number here, you're good to go. When you add a whole number here, when you add that whole number to this whole number, you're going to get a whole number. Okay? I hope that makes sense, the explanation. And the good news is the divisibility test for 8 is really very, very similar. And what is it? Divisibility test for 8. It says a whole number is divisible by 8 if the last three digits of the whole number represent a number divisible by 8. Well, what do they mean? Oh, this is what they mean. Take a large number. Okay. Now, I am only concerned about 888, the last three digits. Okay. Clearly, 888 is divisible by 8, isn't it? So the whole large number, 155,888, whatever that is, 155,888 is divisible by 8. Take a number where the last three digits are not divisible by 8, and this is not, okay? Because the last three digits aren't. You just focus on the last three digits. Now, this is very similar to the divisibility test for 4. There's a subtle difference, as you can tell. For 4, you look at the last two digits. For 8, you look at the last three digits. So let me test if this makes any sense. Sure does. Then the next one is whole number. And I don't get a whole number, I get a decimal number. So the first one is divisible, the second one is not. Now, having said that, so once again, the divisibility test is uh, whole number, if it's divisible by 8, if and only if the last three digits are divisible by 8, and you don't focus on everything else. And why does it work? I'll explain this as well. Its explanation is fairly straightforward, just like the other one, the one for 4. All right, so I'm going to take this same number, 155,888. I can write it as 155 times 1,000 this time, plus 888. Okay, take this and divide both sides by 8. And you hope this left-hand side is a whole number. Well, I'm pretty sure it will be. I'll tell you when. You divide both sides by 8. Okay. If this is clearly divisible by 8 because 1,000 is divisible by 8. Okay. 1,000 divided by 8 is what? 1,000 divided by 8 is 125. So if this is divisible by 8, the whole thing will be divisible by 8 because this will be a whole number, this will be a whole number, and when you add two whole numbers, you're going to get out. Got it? Wonderful. So we have two more tests, divisibility test, and they're slightly difficult. I'm not going to do, well, let's get to it. Let's get to it. 3. Okay. All right. So what did I do here? All right. Divisibility test for 3. Let's take this guy here. It's a little different here. Okay. For divisibility test for 3 says, let's read it. A whole number is divisible by 3 if and only if the sum of the digits is divisible by 3. So what's the sum of the digits? 888. If you add, I'm going to take the example from the previous case. 888 is 24, 25, and 5 plus 5 is 30. So if you add all the digits, you're going to get 35. So let's make this 9. Now what do you get? What's 1 plus? Let's do it here. Okay, let's not mess up. What's 1? I'm adding the digits. Plus 5, plus 5, plus 8, plus 8, plus 9. Well, that's 36. Okay? So this is 36. The sum is 36. The number is not equal to 36, but the sum is. Is 36 divisible by 3? The answer is yes. So is the whole number. Okay? I can give you a large number with many digits, and you will add the sum, add the numbers, the digits individually, and if the sum, which will hopefully be a much smaller number, is divisible by 36, is divisible by 3, so is the whole number. All right. Now the question is, why does it work? It's a perfectly legitimate question, right? Okay. It's a little hard, but I will try to explain it to you, okay? Because it's something that I think you should understand. I'm going to give you a simple example, okay? Your book uses ABC. I'm going to take this number 3, 4, 345. If you add 3 plus 4, which is 7, 7 plus 5 is 12, 12 is divisible by 3, this number should be divisible by 3. Okay, but why does it work? Why does it work? All right, so I can write 3 as this, 3 times 100 plus 4 times 10 plus 5. You can always separate it like this, isn't it? Okay, now on top of that, I am going to separate 100 into 99 plus 1, 4 into 9 plus 1, and I'm going to leave 5 alone. Okay, now I'm going to distribute 3 over. Okay, what do I get? 3 times 99 plus 3. 4 times, not, I'm going to distribute 4 over, 4 times 9 plus 4. What's happening, guys? Do you see how you're isolating the digits 3, 4, 5? Now, on the right-hand side, cluster the digits together. 3 times 99 plus 4 times 9 plus 3 plus 4 plus 4 plus 5. Now, this will always be divisible by 3 because 99 is divisible by 3. Okay? This will always be divisible by 3 because 9 is divisible by 3. When you use this technique and separate into 99 plus 1, 9 plus 1, here, if we had one more placeholder, if we had another digit here, it would be 999 plus 1. So you're always going to be left with the sum of the digits. Always. If you can test or prove that these are divisible, this sum is divisible by 3, you know you're going to get a whole number. Okay? And the good news is the divisibility test for 9 is really identical. I'm going to read it out, but I'm not going to prove it. What does it say? A whole number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. Same thing as 3. What about the divisibility test for 6? What do they say? The divisibility test for 6 is if the whole number is divisible by both 2 and 3. So remember the test for 3, if the sum of the numbers is divisible by 3, the whole number is divisible by 3. If the number is even, it's divisible by 2. So any even number, if you add all the digits and you get a number that's divisible by 3, it's divisible by 6. Now, your book doesn't discuss 7. 7 is hard. We're not going to discuss it. Your book discusses 11. I'm not going to worry about 11, okay? So we need to know how to find, we need to be familiar with the divisibility test for 2, 5, and 10, which are easy, 4 and 8, moderately difficult, and 3 and 9, fairly difficult, and then 6. Got it? All right. Let me do a problem from your, that's all the lecture we have. Let me do this problem. This is an example from your book. So I wouldn't mind doing it. You really should be able to do all the problems I assigned from your MATLAB right now, if you understand the lecture. If you can do one or two problems, please send me those problems. I'm going to incorporate them in my videos. Or if you want to have a one-on-one conversation with me, you can come to my office hours. The links are available on Blazeview under the announcement section. It's Monday, Wednesday from 8:30 till 9:30. Now, if you can't come during that time slot, sure, no problem. Make an appointment. I'll meet with you and we'll talk, have a one-on-one conversation. So let's read this problem and solve this. In a maple syrup processing plant, bottles are packed, either 12 bottles in a case or 6 bottles to a case. Manager's inventory found 1238 bottles in the warehouse. How did the manager know the inventory was wrong? Okay, if you pack the bottles into, if you pack the cartons either with 12 bottles to one carton or 6 bottles to one carton, total number of bottles should be divisible by 6. It's to be. So let's see if this number is divisible by 6. Now, I'm not going to use my calculator. Okay. 1, 2, 3, 3, 8. Okay. Now, clearly this is even. This is divisible by 2. Right? 8 is divisible by 2, so is this number. Is this divisible by 3? Let's check. 8, let's check here. I did say I won't use my calculator, but I'm going to use it in a different way, and that's legit. 17. Is 17 divisible by 3? No. So this number is not divisible by 3, and this number is not divisible by 3. So it cannot be divisible by 6, so the answer has to be incorrect. So once again, guys, on the exam, I will ask you to explain things because I know you can use your calculator when you take the exam, right? And that's fine. I don't see a huge problem, but you have to know how to explain things. For certain problems, I will ask you to give me a decent explanation. Okay, so be aware of that. Keep your notes handy. It's an open book exam. Other than that, I think, guys, you should be able to solve all the problems from MATLAB. Again, if you cannot do some of the problems from 4.1, you want to contact me. And when you contact me, please mention your course name and give me a screenshot of the problem. Ideally, you should also tell me what section it's from so that I can share with the whole class. They'll be able to follow the video properly. Other than that, I don't have anything for today. I'll see you next class. Bye bye.